Hello everyone and welcome to Unacademy classes. My name is Abhishek Mishra and today in this class we are going to discuss some common mistakes that students make in thermodynamics, and I will share with you some tips and tricks so that you can avoid them. So before starting this class, let me just open the chat so that I can see what you are asking and answer your questions, and overall I can interact with you. So let me just open it. So if you have attended any of my previous classes where I have discussed common mistakes, I have done this for manufacturing subject, then you should know what to expect. We should be going uh, and discussing questions here, and from that question we will be seeing what are the areas in which there are potential to make mistakes. So the video is fine, running fine, we are live, and also it looks like the stream is perfectly in good condition. So let's start the class. Again, as I have discussed before with you in common mistakes series that I am taking, we will be going through questions, and in that questions, in every question we will see what are some potential mistakes, and I have collected accumulated questions where mistakes are bound to happen if you are not just fully paying attention, or if you are just not reading questions properly, or due to some misconcepts also. So we will clear all this thing in this class, and this class that will be around 1.5 hour or 2 hour will be totally worth it. If you just stick with me for that amount of time, you will feel that you have gained a lot from this class. So without further ado, let's start the class by first introducing myself to the students who are new, and then what we'll do, we will talk about Unacademy subscription, because it is very important to you that you know about the Unacademy subscription, because there are some very good deals going on, and new courses that are starting that are going to help you for GATE 2021, and also if you are planning to give GATE examination uh, after the year 2021, that is 2022, you will be just you should look into this new courses that is going to happen, where you can study in a relaxed calming manner and cover your whole GATE syllabus in that way. So let's start the class. So this is about me, and I have secured All India rank of 662 in GATE 2020. I have completed my MTech in 2019 from IIT BHU Varanasi, and I've got a good teaching experience of 2 years in mechanical engineering subjects. Some of my interests are listed here: photo editing, video editing, cricket, football, and I like all sorts of games. So I will be taking this entire class in English so that I can reach a lot of students. A lot of students can watch my class, assess it. So as you can see, I have prepared for GATE examination, I have taught for it, and I have scored, I think, decent marks there. So the tips and tricks I have accumulated over the years, and which are, by the way, over the years that I have accumulated them, they are not just came or come to me in 1 year or in some months. There is some years work into that, so you will be getting benefit from my experience. So that will help you a lot, because I am going to just provide you all the details which is going to be helpful going forward. So so you should totally follow me on unacademy.com, because I am taking regularly two classes there. I have started to take two classes per day. So today also I have already taken one class at 1 p.m. thermodynamics revision class, in which I did a rapid quick revision, and that revision was mainly I discussing some important concepts, and there was a lot of students who was that particular class, and we interacted a lot. So I think the class was very fine, and if you are looking for a class where you can study with other students, then you should follow me there, and just arrive 1 p.m. on Unacademy to attend the class. And also you can attend classes at 10 p.m. when I will be teaching about the manufacturing concepts and some mechanical engineering basic things, like this common mistakes class. But I'm planning, instead of just one subject, to cover whole mechanical engineering common mistakes in some of my classes, special classes that you can watch absolutely for free. But you have to first follow me so that my whole schedule can be visible to you, and you can just check out which to follow, when to follow, and be present there live. Because classes should be watched live on online classes, because if you are watching recorded classes, then the whole interaction thing, whole discussion thing will be just gone. So I recommend you to absolutely watch live classes, and just inform your friends and other students also, because as much as students come to a live class, and all the students can discuss, so it will benefit each and every one of you, because it will create a very nice healthy environment in which you are going to be finding yourself very engaged and in a very competitive environment. So when you are going to Unacademy, you require a code to watch free classes on the website and app. So this code that I'm providing you right here is for you to watch the live classes and recorded sessions and download notes and take part in quizzes. So ABHIMI in all capital letters is the code. If you have not downloaded the Unacademy app yet, so just go and download this app, because this app, first of all, is absolutely free. Second, this app has everything that you require when you are studying online. This app has the live classes, recorded classes, test series, quizzes, short quizzes, 5 question, 10 question, and schedule. You can see which teacher will take which class when, and you can also select notifications for a particular class also, so that you can get notification for the classes you are interested in only. And also you can just uh, watch the classes in such a manner where you can interact a lot more. You can take part in live answer polls that will be given to you during the classes going on. So overall, Unacademy app is designed in such a way that is far better than YouTube, because YouTube is a general video streaming site, unlike Unacademy, which is specifically designed by keeping in mind that it is going to help the students who are preparing for this competitive examinations. And there are multiple new courses batches starting. So 21st December 2020, EE and ECE batches are starting, and mechanical and CE batches are starting from 28 December. And you should just subscribe to Unacademy and start from day one, because each and every day new concept will be taking place. Yes, you can say that you can attend classes, recorded sessions, but right now you are getting Unacademy subscription at a very reasonable price. And the second thing that I am going to point out is that by attending classes live, you are going to get a lot than attending a recorded classes, because live classes obviously will make your whole interaction a lot better than recorded classes, and you will be encouraged by the teachers, educators will encourage you to just solve the questions there that they are giving live. And what will happen, if you are solving a question just after reading a topic live, then you will there only clear all your doubts if you are having when solving a question. So that will save a lot of time, and this is the smart way to study. So I think you should just look into this and use this code to get 10% off. And if you are not using this code, then you are obviously going to lose money, because this code is to be used, and this will not be visible to you if you are not aware. And therefore I'm just pointing it out. Use this code and take this 10% off. And here are the benefits that you will get when you subscribe to Unacademy: daily live classes, live test and quizzes, structured courses, unlimited access. So all things this you will get when you subscribe. And the most important thing here is that the courses that are going on right now in the Unacademy's website or application is mainly focused on revision and crash courses. So if you are going to give GATE examination next year 2021, so right now the best approach to study is to attend revision classes, do revision, and then give test series. And all of these are available or provided when you subscribe to Unacademy. So just make sure that you are following this approach if you want to score good marks. Just do revision. No need to learn theory, all the theory that is going to be just needlessly there. Just attend the revision classes, because right now the time is not there to cover each and everything in very detail, because that will obviously take a lot of time. And for that you need to be studying for at least 6-7 months in advance if you want to study in a relaxed manner, calm manner. And that's why I've told you that GATE 2022 and 2023 classes are going on. So if you want to study in that manner, which in which you want to study everything in detail, not in a hurry, or not binge watch, or not binge watch classes or binge attend classes, you should be then taking the 1 year or more Unacademy subscription. But right now, what you want, if you are going to give 2021 examination, even if you are studying from the several months, you need to revise. It is most important thing, because if you are just forgetting formula then and concepts, then there is nothing a lot that you can do. So what you need here is to attend revision classes, crash courses, and then give test. And it is very important after giving test for you to analyze them. Analysis will be provided by Unacademy, and work on your mistakes, because there is no benefit in just giving test and not working on your shortcomings. So new subscription prices is shown here. 10% off code is also shown. The same code that I have discussed a lot time. It is just going to be it is providing you a lot. So it is a very handy code to have. Free classes just before subscription, you can watch that to get an idea what Unacademy is. And also to take part in quizzes, download notes that are free. You need this code, and you need this code to get 10% off. And after using this code, this is the final discounted price, which is the minimum price in which you can get an Unacademy subscription for. And here you can see that no cost EMI option is available on 6 months and above subscription plan. And the best plans to choose are 54%, 61%, 61% off. So these plans are the last three plans are the ones which are providing you the most discount. So if you are planning for a long time study, then this is the absolute best plans to go with, because even after this discount provided by Unacademy, you have this chance to get 10% more discount and have these resources available to you during this long amount of months. And this is also going to be important for your interviews and for other PSU examination. Even if your main aim is GATE 2021, you can look into these plans. But if you are not just sure about the Unacademy, you can watch free classes. Even after that you are not sure, then you can just subscribe for 1 month, and then after you can just extend your subscription if you are resonating well with the Unacademy services. And I think you should totally subscribe for 12 or more months, because Unacademy, when you will study from there, you will find that it is a lot more advanced. The application, the website, the amount of educators there, the questions, test series, so a lot of things are going on. You have also a GATE combat that is going on, a quiz series where you can win prizes, so you are getting best of both months. So you should totally subscribe from today and start doing that revision for GATE 2021. And if you are thinking that this is not reasonably priced, then let me assure you that this subscription plans are very reasonably priced, because the amount of content and the quality of content that you will be getting, the amount of options that you will have to study from educators, different type of educators, is very valuable. And this subscription, you should totally look into it, and if you have the budget, then you should go for it. And this is for plus type subscription, which are for those who need classroom type experience. And then you have this iconic subscription, which are for those who need more assistance. So if you need more assistance, like a personal coach, personalized test series, then use this code and get this subscription in this least possible prices that is shown on your screen. And again, these are very reasonably priced, because just wait a second, just relax and see that here you are getting personal coaches, okay, personalized test series, study planner, preparatory study material. So everything points out to for you to just concentrate on your study and take advantages of this things that is shown here. So I think you should totally check out Iconic if you have the budget and if you have the need. But if you are okay with the classroom experience, which by the way is also very good, because a lot of students there will be just studying, and you can interact with them, and the educators will be discussing with all of you. You all will be taken care of. So that thing you can also be rest assured that will be provided. You will be absolutely taken care of during the live classes. So you can also go with plus subscription. Just you have to select the plan which is suiting you and just start preparation, and just subscribe today, because there is no point in waiting and just subscribing after some months, because then you will get the same thing, but now the time is less. So if you have the budget, just go for it, and don't forget to use this code, because you will get a lot of discounts, a lot of savings if you are using this code. So that's it for the Unacademy subscription discussion. I hope you have understood the things that I have discussed here. I've discussed here and told you the things that is obviously, if you follow, you will find yourself in a very better position for GATE examination and also ESE examination. Now let's start the discussion here. Our first thing that we are going to discuss is by looking into this question. So we have this net work done to be find we have to find this net work done in joule for a closed system shown in the given PV diagram. So it is not shown, but let me draw it quickly. So this question, I'm going to first read what is to be find, and then we will talk about what are the potential errors or mistakes a student can make here. We will go through all these potential mistakes, and you can say that why we are, or why I am going through this potential mistake. I am never going to make this. So that is one thing that you have to just take out from your mind. You can make errors even if you are 100% sure that you are not going to do it. During your GATE examination, you will find that there the situation is very different. There you can make errors by a lot of factors, like for example, if you are going to do questions, and if you are not doing questions accordingly, and you are finding that 4 or 5 questions are not solved or answered by you, then you will say, or you will feel like that you are going to get less marks and or score less marks. So that things, if it is going to happen, there is not 100% surety that this is going to happen for everybody and for every time, but there are chances, and that chances you should not take for granted. Therefore I think you should be aware of this potential errors, so that when the time comes, you are solving the question, you are aware that this thing I don't have to do, and this is the thing that I have to do. This basic thing you have to be very clear of. And for that, I am discussing this potential errors for you to always remember and not make mistakes. So net work done for a closed system shown in the given PV diagram, and I am drawing this so that we can then discuss the errors involved there. Again, students, you should watch the classes live, because that thing, classes, watching classes live is absolutely the right approach here or anywhere to study online, because the amount of interaction that you can do on the spot problem solving and doubt clarification is very valuable. It will save a lot of time of yours, so I am recommending you that. So I have drawn this figure, and now what is the net work done for the closed system in joules for the given PV diagram 1, 2, 3, 4. So you should know that the net work done in PV diagram is the area of the cycle. So here the area of the cycle we have to simply calculate by the things that is given in the question, the values. So I am going to first calculate the area like this. So area will be, so area of the cycle will be area of these two triangles let me adjust the camera a bit because so area of the cycle is area of triangle 1, 2, 3 plus area of triangle 1, 3, 4. So what is the area of triangle 1, 2, 3? Area of triangle 1, 2, 3 is, so you should solve this question I think in 60 seconds. That is more than enough time. So I'm just quickly going through this. It is area of triangle 1, 2, 3. So half into base. What is base? It is 5 meter cube. And what is the height here? It is 15 kilopascal plus half into, again we have the base to be 5 and the height is 15. So here the answer is coming out as 75. So you have the option which is having 75, 37.5, 75, 000, 37500. But now comes the discussion where you can make error. So even if you have obtained the answer, the value, and after calculating the value, if you just directly go to options and see the 75 and picked this 75 as your answer, then this will be wrong because your work done is hours in joule, and you have to make this habit of every time when you are going to answer this question to see what units are the answer asked in and answer only in that unit. And here the area that you are calculating, due to this pressure being in kilopascal, you will get your answer in kilojoule. So the answer in joules will be 75,000, and that is the option C. So this is the correct answer, not this, because work done here is not asked in kilojoule, it is asked in joule. So even after calculating the answer, you should not just see the value and get the picked the answer, because the examiner will uh, give this type of tricks or this type of things so that you can make this error. So here or anywhere in GATE examination, whenever you are finding a value and then selecting an answer, just before doing that, see what is the value of the, what is the unit of the value in which the answer is to be given. And here it is in joule, therefore we are giving the answer in joule by converting kilojoule into joule. So that's why the answer C is correct. And there is one more thing that you can see in options. If you have calculated only this half area, that is 1, 2, 3 triangle, and after calculating this half area, somehow if you just obtain the value 37,500, and after calculating and obtaining that value, if you just see the option and selected an answer without doing full question calculation, then you will get the wrong answer obviously. So you don't have to just calculate the value and look for answer. You have to find do the full calculation with the right units, then only you have to pick the correct option among the ones given. So that is our first common mistake discussion. I hope you find it useful. Now let's move on to the other question here. 1 kg of air initially at a temperature of 127 degrees Celsius expands reversibly at a constant pressure until the volume is doubled. If the gas constant of air is 287 joule per kg Kelvin, the magnitude of work transfer is dash kilojoule. So this question is very good, and it is very easy also. So I don't think that here I have to just do this question, because this is a common mistake class. So I'm going to change this question a little bit, and then there we will discuss what are the errors one can make, because right now this question is quite straightforward. You have to find the answer uh, by using the common basic things that is learned by you. But this is a official GATE question, so I'm changing this a little bit so that we can discuss some potential errors that you can make. So 1 kg of air initially at a temperature of 127 degrees Celsius. Let's change this expands into compresses reversibly at a constant pressure until the volume is, since this is expanding, we are having this volume reduced, so let it be halved. If the gas constant is this much, which you should or totally know, if it is air, then this is the characteristic gas constant. Magnitude of work transfer is asked in kilojoules. So now there are some areas where mistakes can happen if you are not doing this question with your full focus and not reading everything that is there given in the question. So let's see the solution of this, and then I will also during that discussion talk about the mistakes that one can make. So mass of air is given as 1 kg. The initial temperature is given as, let's take 127 degrees Celsius, so it will be 400 Kelvin. Then we have its volume Vi, we don't know that, but Vf is Vi by 2, and gas constant we know the value. Magnitude of work transfer is asked. So work, and this process is so what is this process? So in this process, let's see that what is it, a constant pressure process or not, or something. Yes, it is a constant pressure process, it is given, so I somehow missed that. So it is a constant pressure process, so the work done will be, net work done will be P into change in volume. So we don't know P here, and to calculate P, what we have to do, we have to use the ideal gas law, which is PV or PVI. Since we are talking about the pressure, it is constant, so it will be P, and then we will have MRT, mass is already given, R is your characteristic gas constant, and T will be Ti. So from here the pressure is coming out to be in the form of Vi, because Vi is also not given here, so it will be simply MRTI divided by Vi, and M is 1, R is 287, and Ti is 400. Then we will have this Vi. So that is all fine. And what will be delta V? Always remember, here is one more mistake that students do somehow. They don't take, while calculating delta V, you have to take the final volume minus initial volume. So don't make this very silly mistake of taking larger volume by smaller volume. It is not, that is to be taken here. We always take final minus initial. So final volume is half, initial volume is Vi. So we will be left with this, and by taking this P as this value that we have calculated, so what we will be left, we will be left with minus 1 by 2 287 into 400. So this will give us the answer, our work done, and this will be in joules because 287 is in joule. So 287 into 400 divided by 2, and this will be minus 57.4 kilojoule. So here comes some other points to discuss, because first point that I have discussed, it is when you are very new, then you can make this mistake of taking larger volume by smaller, but you should be taking final by minus initial. And the other mistake that is very important, that is the main objective of mine to bring this question here, is that what you will write here as the answer will be 57.4, not the minus sign. So that is why I have made sure that this question is, I have changed it here so that you can also see, if you are writing this 57.4, then only your answer is correct. If it is minus 57.4 that you are writing, then you are writing it wrong. You are not writing the correct answer, because what is asked, read the question properly and you will yourself find it very clear that minus sign is to be not included. So what is given is you have to find the magnitude of work transfer, and magnitude means only the value, not the plus or minus. Plus sign will not matter, so not the minus sign. So magnitude means only the value, not the direction. So minus sign is showing us the direction. Since compression is taking place, so minus sign is showing us that the work is done on our system, and if work is done on a system, then it will be negative, because our standard assumption is that in all our here derivation and the relations that we are using, that whenever work is done by the system, so the word by is important, work done by the system we take it as positive, work done on the system we are taking it as negative. And since in compression we have to provide work to the system as input, so the minus sign will be obviously there. But magnitude of work transfer is asked, so don't write minus sign there. Look for this magnitude term when you are writing this work transfer, heat transfer, and also you are writing things like strain value. So in strength of mechanics, so magnitude term whenever it is coming, what you have to do, you have to leave the minus sign and you have to only write the value. So I have changed this question so that you can just look in this potential error that students can make. Now we will move forward. So if a closed system is undergoing an irreversible process, entropy of the system, what will happen to the entropy of the system if the system is closed? So for a closed system there will be no energy interaction taking place, only mass interaction can take place, and an irreversible process is going to occur or is occurring. So due to that irreversible process, what will be the change in entropy, or what will be the entropy of the system become? And the options are must increase, always remain constant, must decrease, can go up, can go down, that is can increase or decrease, or remain constant. So if you know the answer to this question, you can just write the correct answer on the comment section so that I can see if you. So Banuranjan, so welcome back Banuranjan to the class, and I hope you are doing well. So what is the answer? It is D that you are telling. So can increase, decrease, or remain constant. So that is absolutely the correct answer. But since this is common mistake class, so I think you should be aware of what common mistakes here happen by the students. So let's discuss that also. So here closed system is given. So for closed system, one may think that this system will have no energy interaction, only mass interaction. So only mass transfer. no, sorry, only energy transfer. So that I was obviously telling wrong, so apologies for that. Only energy transfer. So closed system only will have energy transfer, not this mass transfer. So one may think that for this we have this irreversible process, and for irreversible process there will be entropy generation, and that entropy generation is always positive. So that positive entropy generation can lead to this entropy of the system always increasing. Okay, but that is not the thing that is happening. Because of the irreversible process there will be 100% entropy generation, but due to energy transfer the entropy can decrease through that or increase through that, or it can just not change due to this energy transfer. So all these three things are possible. Don't get confused by seeing this irreversible process and thinking about entropy generation, which is always positive, because energy transfer here is making sure that all three cases are possible. Now here comes a very good question from the GATE official question paper, and here I am not going to solve this question fully because this is a common mistake class. So we will look into what is the common mistake that is going to you should take care of. So nitrogen gas molecular weight given is enclosed in a cylinder by a piston at the initial condition of 2 bar 298 Kelvin 1 meter cube. In a particular process gas is slowly expanding under isothermal condition. So isothermal condition is there until the volume becomes 2 meter cube, and heat exchange occurs with temperature 298 Kelvin as the atmospheric temperature during this process, and we have to find the entropy changes for the universe during this process in kilojoule per Kelvin. So if Manuranjan you are still watching, and if you want to do this question, then I think you should totally do it, because this will clear a lot of your concepts, and I think it will not take more than 2 minutes to do this question. So I recommend if you do this question, then it will be very beneficial for you. So Banuranjan, just provide me the answer in 2 minutes, because this question is very fine. And there are multiple regions in which error can occur. So if anybody who is watching this live want to do this question, you should totally do it. Then we will discuss what are the potential mistakes that one make, and if you are making the same mistake or not. If you are not making, then it is very good, you are on the right path. But if you are making this, then look for them and don't repeat them. So we have to find the entropy change for universe here. So you should know for ideal gas what is the entropy change formula, and if you are unaware of that, let me just write it down. So Varuranjan, have you got the answer yet? I am still giving you. So yes, correct answer is 0. So that is absolutely correct. But now, since you have obtained the correct answer, I think you should be aware what type of mistakes you should be aware of, so that you are not going to make, even if you are in a hurry or stuffs like that. So nitrogen gas molecular weight is 28. So the first thing that you have to be looking into is to not take R, that is the characteristic gas constant, as 2.87. This is only for air, and it will change based on what gas is asked in the question. So this thing you have to first take care of. Then the second thing is, in this question it is asked for you to find entropy change for the universe. Okay, so entropy change for the universe is asked, not the system. So don't just calculate the entropy change of the system using this formula, because if you are calculating entropy change for the universe, this will have some value, and that value I think may be given in the option, and you can then just select that as answer. But that will be wrong, because for universe you have to consider the entropy changes for both the system and the surrounding. And what will be the entropy change in the surrounding here? The surrounding will have this entropy change see, you have this first law of thermodynamics as Q is equal to delta U plus W. So since this is a isothermal process, there will be no, for ideal gas there will be no internal energy change for isothermal process. So your whole work that is done will be equal to what is the heat interaction taking place. And that heat, since work is going to be positive here because gas is expanding, so work will be positive, and that positive work will lead to Q being positive also. And since Q is positive, that means your surrounding is losing heat. So your surroundings entropy will be minus Q, because it is losing heat, is giving heat to the system, divided by the temperature in which this heat transfer is taking place. So that will give you what is the entropy change in the surrounding, and the universal entropy change will be delta S universe will be delta S system plus delta S surrounding, and you will see that it is going to come 0, which Banuranjan has find it very correctly. But always make sure that you are also checking for mass here, because here mass can be calculated and your answer is asked by multiplying mass. It is not asked by in the specific form. So mass can be calculated here, but the mass is not given in the question. So first you need to calculate mass also, so that you can get this ideal gas entropy correctly. If you are not calculating mass and therefore missing that term, if it is not given in question, check out if there is a way to calculate it. So I hope you have understood what are the potential mistakes students can make, and you are aware of these mistakes, and hence making your concept stronger. So now let's talk about this question, Banuranjan. This is a very good question. Here also we will cover a lot of important things, a lot of important mistakes that students can make. Your concepts will be made further stronger when you do this question. So 1 kg of ethane, ideal gas, is compressed from 1 bar 30 degree Celsius according to the formula PV raised to the power 1.2 is equal to constant. Until the pressure is 6.5 bar, calculate the heat flow from the cylinder and its direction. Molecular weight of ethane is given 30 gram per mole, and Cp is given as 1.78 kilojoule per kg Kelvin. And you have to find the answer, that is the heat flow in this units. So Banuranjan, are you ready to do this question? Are you solving it? Or should I just tell you what are the mistakes going on here? Because it is one of the better questions to do, and I think this is not asked yet in the GATE examination. So yes, do this question again, 2-3 minutes, just take it, because it is a little bit of lengthy question, and then provide me the answer there. So I will write here what is given. Yes, 90 seconds is also fine, but I think you should you can take 2 minutes or 3 minutes also, because this is a little bit of lengthy question. So 180 seconds, 3 minutes is also fine, but calculate the answer correctly. So since this is a polytropic process, so let me provide you the formula. Uh, so work polytropic will be P1 V1 minus P2 V2 divided by n minus 1. Then we have this heat transfer in a polytropic process, which will be W polytropic into gamma minus n by gamma minus 1. So this two things is important to find this question answer. So n here is 1.2. Calculate heat flow from cylinder and its direction. Yes, it is from heat flow from cylinder. So yes, what is the heat flowing from the cylinder? That is from your system to the surrounding. This is one of the questions which is little bit on a harder side, because there are a lot of things that you have to do here. So I think I should now start doing the questions. Since Manoranjan, you are uh, ahead, you can continue your solution. So we have this pressure initially, temperature initially given to us, and mass of the ethane given to us, and we have pressure finally also given to us. So first we will find what is V1. So P1 V1 is equal to MR T1. From here V1 will be, what will be the V1 value here? It is going to come out as so V1 is coming out as 0.84 meter cube. So Banuranjan, have you calculated volume 1 initial volume, and what is your initial volume coming out? Can you just write it down in the chat so that I can see? It should be meter cube only, not meter cube per second. You are not calculating volumetric flow rate there. So take care about the simple units here, only meter cube. And since this is also, you can see closed system, so no flow will be there. So V1 is calculated as this much, and you have to be what you are using here is molecular weight of ethane is 30 gram per mole. So just for your information, whenever molecular weight is given in 30 gram per mole, you can also take it as 30 kilogram per kilomole. That will be same thing, because if you multiply 1000 above and below, it will become kilogram and kilomole. So this is also you can remember. And to find characteristic gas constant, you have to divide this universal gas constant by the molecular weight. So don't make this mistake of taking the characteristic gas constant everywhere 0.287. It is only for air, and here we have to deal with ethane. And what will be the volume 2 V2? V2 will be P2 V2 MR. So Benny, good evening, and we are doing this question. It is a very good question, and Manuranjan is also joined us here, and he is also finding this question answer. And in this question, there are a lot of potential to do mistakes. So if you know how to do this question, general method, then you can also attempt it. It will take, I think, around 4 and 5 minutes more to discuss here all the things that I want to discuss. So you can solve that this question in the meantime. So we have ethane gas compressed from, so this will be our second thing, and here we don't know T2. Okay, so how to calculate V2 then? Have you calculated V2, Manuranjan? We have already calculated V1, and now we are looking for V2 because we have to find this polytropic work done. No, the final answer is not that. It is wrong. It is not 75.25, and there is no. So V2 is 0.174. So let us see. To find V2, we have to use this PV raised to power 1.2 is equal to constant. So P1 V1 raised to power 1.2 is given, and P2 V2 raised to power 1.2. From here, V2 is coming out as, yes, it is coming out as 0.176, and your answer is also similar to that. So it will be the final volume. Now what is the work done coming out as? Work done will be P1 V1 minus P2 V2 divided by n minus 1. So it will be in kilojoule. You have to give that answer. So it will be, so it is coming out as minus 153.76 kilojoule. So this is what your polytropic work done is coming. The minus sign here is very important. So let me just write polytropic work done is coming out as minus 153. So minus 153.76 kilojoule. And again, minus sign is important because we have to find the direction also. Give the answer by keeping in mind this direction. So Q polytropic, what will be this? It will be W polytropic. So Banuranjan, what value have you taken for this gamma minus n? What is your gamma taken by you in this question? And have you written this minus sign? What is gamma? It is 1.4, but it is 1.4 for air because this is the ratio of specific, this is the ratio of this specific heat at constant volume and pressure, or constant pressure and volume, and this ratios will be, for air it is 1.005 divided by 0.718. So it will be 0.005 divided by 0.718. So it is coming out as 1.4. But we are not talking here about air, do we? We are talking about the ethane gas. So for ethane gas, Cp by Cv ratio will be completely changed. It is not always equal to 1.4. That was the main thing, main reason of me selecting this question and making you do this here, because here a very common mistake one can do is to take gamma equal to 1.4 even if air is not involved. So what will be the correct value of this specific heat ratio constant, Cp by Cv? You have been provided with this Cp, and for Cv, how to calculate it? You can calculate it easily because you also know the R, that is the characteristic gas constant, and Cp minus Cv is equal to R. So Banuranjan, what is the gamma for ethane gas here? Yes, that is also one way to do that. So that is also one way, is Cp is equal to gamma R by gamma minus 1. So you can do that both the ways, but tell me what is the value of gamma here. That is the specific heat ratios. This is your question. So what is the value here? My Cv is coming out as 1.5028 and Cp is 1.78. So by dividing this, now calculate the answer. Since you have calculated this specific heat ratios properly, so calculate the answer now. I hope you can calculate it. You have this heat polytropic and you also have this gamma, now the correct one. So what will be the answer coming out here? So what will be the answer coming out here? Q polytropic. With the correct sign direction, you have to provide me the answer here now. So you have this work polytropic, you have N, you have gamma. So the correct answer will be, so yes, 13.37 is the correct answer. It is written in my answer key as 13.36. So 13.37 is the correct answer. It is around that only, and it is with the plus sign. So I hope you have understood what I wanted to share with you with this question. That is, gamma specific heat ratio is not always 1.4. It is different if you have given this Cp and Cv different and you are getting this different ratio from them, and you have to be very well aware of that fact. And therefore what we learned from this question, let's summarize all this thing. First, we learned that R, that is the characteristic gas constant, is not always 0.287 kilojoule per kg Kelvin. It can change depending upon the gas molecular weight, and here we found out R as different than this air value. Then we found the gamma different and then just put it there in this formula and we got the answer. So there are multiple things here that we see and that we saw, and here you can also look into this question. It is very big, lengthy question, a little bit hard also. So this type of question can surely come in your GATE examination. One or two this lengthy and hard type of question can come, but the main thing is not about how hard the question is about what is the concept that we learned from here. So let's move forward. So here is one of the questions that I did in my one of the recent class, and I am not going to solve this question fully here. We are just going to talk about what is you have to look here. Since this is not that type of hard question, here you are going to be you are given what Cp is in terms of T, and you are asked here about the change in enthalpy in, the unit should be here, kilojoule per kg. So change in enthalpy dH you have to calculate, or delta H you have to calculate when the process is going from T1 to T2, and T1 is 30 degrees Celsius, T2 is 150 degrees Celsius, and this will be, since this is specific enthalpy change you are given, so just write Cp dt integration 1 to 2. So after you have written here Cp from the above equation, you will find this as your equation, and this dt, you have to integrate this, and this term will become delta H, that is H2 minus H1. So this is what you have to find here. And the thing that you have to notice is the temperature is to be put in, it is given in degrees Celsius, but it is to be put in Kelvin, because here it is stated specifically that in this equation temperature is in Kelvin. So if you are not putting temperature in Kelvin, you are going to get the wrong value, which is not according to what examiner has given this equation. And just convert this T 30 degree into 303 Kelvin. This will 150 degree will become 423 Kelvin, and then just solve this question and get your answer. So overall there is nothing. So 116.9. So yes, that is very good, correct answer, Manoranjan. You also did this very I think in a good amount of time. So that is very fine. So let's move forward. I hope you just understand that temperature is to be put in the value which is given. If in the question it is given that here T is in degree Celsius, then you have to forget everything that you have learned before and just do the question according to what is given. Now this comes a question from GATE 2018, and here also there are little bit of things that can make your answer wrong. So since this question is not that big, so I think Manoranjan, you can do this also in 2 minutes. So I am giving you that time, and what is given in the question, that the figure at that is drawn below is showing all the data that is given in the question, and you are going to just provide the answer, that is temperature of the air when the piston will begin to move. So you are given this details, and here when the piston will begin to move, you have to find what is the temperature at that point. So in the meantime, when you do this question, Manoranjan, what I am going to do, I am going to read this question. So air is held inside a non-insulated cylinder using a piston which is having a mass 25 kg and area of 100 centimeter squares. There are stoppers as seen in the figure, and they are of negligible area. Initial pressure is Pi and temperature Ti, and air inside the cylinder are having this pressure and initial pressure and temperature that is given in the question. Ambient pressure and temperature is also given in the question, and we have to find the temperature at which your piston will start moving. So those of you who are watching this session live can provide me the answer. It is not that big lengthy question. You have to just find, you can do this under this 2 minutes or even 1 minute. So after 1 minute I will start doing this question, and I will discuss what are the potential errors that a student can make, and we will look into them. So since here pressure is given 200 kilopascal and the outside pressure is 100 kilopascal, and there are stoppers here. Okay, so let me just change this. So there are stoppers here, and your initial pressure is 200 kilopascal, which is going to be decrease so that your piston will move, because if the pressure will increase further, what will happen, your piston will stay where it is, because it is not going to go up because of the stoppers there. So the only place, the only region where it can go is downwards. So only direction the piston can move is downwards direction or towards the bottom. So you have to find a pressure which is less than this, and which is the pressure after which your piston will start moving. So you have to find first the pressure value at which the piston and the atmosphere will be at equilibrium. Then after that, if you decrease pressure further, you will get this piston moving downwards. So what we will do here is we will find that final pressure as equal to ambient pressure plus the pressure due to weight of the piston. So ambient pressure is 100 kilopascal, weight is 25 into. Now don't take G value as 9.81, it is 10. Here students just always take 9.81 without seeing the questions. So you don't have to take 9.81 even if it is given 10. If it is given 10, then take that value because that is what examiner is expecting you to take and do this question. So then you will divide it by area. So what will be the area here? Area will be 100 centimeter square. So centimeter square will become in meter square after we convert it like this. So this whole thing that we are calculating, what will be the unit here? It will come out in Pascal, but our 100 is written in kilopascal. So don't make this mistake of taking this into Pascal only. You have to convert this into kilopascal so that you can add this with the P infinity if you are taking P infinity as kilopascal. So what will be the answer here? It will be coming out as 125 kilopascal. So this will be your final pressure. So your piston, let me draw it here. This is your piston. So Panuranjan, your answer you have given 337, and so look into this. We have this question, and I will just tell you if this answer is correct or not. So let's see. And let me give you information here. Your answer is not correct. So we will see why it is not correct, and you can look into the question. So the first common mistake you did there was not read the question properly and giving the answer in Kelvin. That is one of the mistakes that I find a lot of students did when this question came in 2018. So you have to find the answer in degree Celsius. It is clearly stated, and the examiner is expecting you to do this same error. Therefore he or she has given this degree Celsius, and we have this ambient pressure P infinity, we have this weight, pressure due to this weight, and we have inside pressure which is final and equal to 125. And if this 120, this pressure becomes less than this 125, your piston will begin to move because the outside pressure plus the weight will be increased or more than that. So now apply the ideal gas law. You have this. So what we have here is initial pressure, final pressure, and we can calculate volume here. So let's calculate volume first of all. So it will be 200 into, or we don't have to calculate volume here because this process of 63.5 degrees Celsius. So I am not sure if that is right or not because I don't remember the answer exactly. So let me calculate it and then see it. So what is, so Pi, yes, that is the one that we are doing. So Pi to Pf, this pressure initial is changing from Pi to Pf, and during that time there is no volume change because of the stoppers, and due to that we can say P is directly proportional to T. So P1 by P2 will be equal to T1 by T2, and what will be the answer here? The T1 is 400, P2 is 125, and 200. So our final answer is coming out as T2 is equal to, just wait a second, I somehow just erased it. So the final answer is coming out as Panuranjan, not 63.5 but 147.625. So that this answer I remember, this is the correct answer. And let me write it more clearly here. So 147.625 is the final answer of this question, and just see what mistake you are making and correct it and obtain this value or not. If you are obtaining this, then just write it down in the comment section. 147.625 degrees Celsius. So Manuranjan, just check your calculation and see if you are getting this answer or not. So you are getting 63.5, which is here. Always remember, when you are taking this ratios here, you have to write this in Kelvin, not degree Celsius. And you are going to get your answer in Kelvin only, the T2 temperature. And if you are doing this ratios or multiplication in degree Celsius, then your answer will be wrong. So always take this in Kelvin, because remember, you can remember from this that your PV is equal to MRT. Whenever you use this formula, what you take this in the kilopascal or pascal, this in meter cube, and this temperature is always taken in Kelvin, because here it is in multiplication and here it is in division, and it is coming from the same ideal gas formula. Therefore we are taking this also in Kelvin. So always take this in Kelvin. And can you find the right answer here now? 147.625 is this the answer you are getting or not? By converting this 400 degrees Celsius T initial, you will be getting 673 Kelvin, and then there is very simple calculation there so that you can get the final answer. So Manuranjan, just solve it so that should we move forward? So we discussed here very important thing. So are you now able to get the right answer by writing T1 as, so what you are taking? So let me just write it here at this region. So your P1 is 125, P2 is 200, T1 is 673 in Kelvin, and T2 is you have to find. So from here you will be finding T2 as 673 into 200 divided by 125. Sorry, it will be calculated as this. I have written here, it should be, okay, so what mistake you were making? So it should be 200 divided by 125, because P1 is 200 there. So I think now you can get the correct answer. So T2 is coming out to be 420.625, but again this is Kelvin, this is absolutely correct value of T2, but this is not our answer because we have to give the answer in degree Celsius. So you didn't convert this centimeter square into the meter square, so therefore your unit got differentiated, and you didn't got your this calculation correct, because the calculation can only be done if kilopascal is added with kilopascal. So that is also one mistake, and this mistake is done by you. So you should be very aware that you are not going to make this mistake again, because what happens, a student which is making a certain mistake, he or she may repeat the same mistake. So be very careful and look into the units. The only way to do this question right, or any question right here, is to look properly in the units and solve in a very tidy manner. So yes, solve accordingly. You will find this 125, and I think you can do the rest of the thing properly. So we should move forward. But this was a very nice question. There are multiple potentials of mistake here. And now comes another good question. And this question can again be done in just 1 minute, or you can do this, take 2 minutes also, but do this question rightly, because there is again certain possibilities of making error here if you are not careful. So in a constant temperature process, that is isothermal process, 100 moles of an ideal gas at temperature 300 Kelvin attains a final volume V2. Work input during this process is 249.42 kilojoule. We have to find initial volume V1 and final volume V2 relation, so that this whole uh, system is satisfying that relation. So what we are given? We are given with this 100 moles of ideal gas with temperature 300, and work input is given as and N is given as 100 moles, T1 is 300 Kelvin, and it will be equal to T2 because isothermal process, and we have to find relation between V1 and V2. So again, take here 60 seconds now and do this question. So what will be the correct answer here? Banoranjan, have you calculated this answer or still doing the calculation? See, 60 seconds. So now see, you are giving the correct answer, that is V2 is equal to E V1. So this is your correct answer, Banoranjan. Let's see. So what is the so what we are going to do? We are going to take this work input as minus 249.42, and I think you have not taken it as minus. Work input is given, and work input means system is receiving work, so the minus sign will be there when you are going to use this NR bar T1 ln V2 minus V1 formula. So that is one of the mistakes here that students do, and originally this question didn't have this option. I myself added this because I thought this is a potential mistake that student can do, and this option was added by me, and somehow you selected that wrong option, Banoranjan. So be more careful about the terms that are given in the question. It will be V2 by V1. So another mistake what can happen here is some students can take 100 moles N as 100. If they are taking R as 8.314, then R is in kilojoule per kg kilomole. So this kilomole, due to this R should be 0.100, not this 100. If you are taking N as 100 moles, then you have to take R as 8314 joule per 8314 kilojoule per moles. So this is you need to be doing if you are taking the term as 100. So or it should be, I think, yes, this is fine. So then what we have to do is we have to, after calculating this n r bar t1, you will find that your ln v2 by v1 is coming out as -1. So your v2 by v1 ratio will be 1 by e, and from here you can get v1 equal to ev2. So the correct answer is, yes, sorry for that, I was thinking about I made some mistake here, so it should be Kelvin. Because then we are going to multiply with temperature and this mole and get this answer in kilojoule. So now the correct answer is coming out as B, V1 is equal to E V2. And I hope, Manuranjan, you have understood what mistake is made by you here, and you can look for it. So I have written, so R is 8.314. So R is 8.314 kilojoule per Kelvin kilomole. Okay. And this is universal gas constant, by the way, not characteristic gas constant. So if you are going to make this kilomole into mole, then what will happen? It will become 8.314 kilojoule per Kelvin. And yes, it is going to be little bit different than what I have written, so I thought that something was off here. So it will be not this, it will be 8.314 divided by this 1000. Okay, so if you are taking that mole here, then you should get convert this kilo into mole so that your n 100 moles can get cancelled. But that is, I think, making you all this more confusing. So what you should totally do is take care that your R, universal gas constant R bar, and this moles are also in the same units. Okay, so let's move forward. But remember, work input, it will be very helpful for you in this fluid mechanics also, where work input is also there, and you have to be very careful that you are taking work input as minus in the equations, because in the equations we are taking work input as minus and work producing as plus. So now we have this question, the next question, and let's see what are, how much question is left for discussion today. So 1 2 3 4. So let's discuss this 4 questions, then we will end this class. So it will take, I think, around 25 or 20 minutes. So this is given V1 P1 temperature 1, V2 P2 is given, your specific heat ratio gamma is given as 1.4, the characteristic gas constant is given as 0.291 kilojoule per kg Kelvin, and we have to determine the heat transfer of the process in kilojoule. So in kilojoule we have to determine the heat transfer, and again here there is one potential place where you can make mistake. So determine the heat transfer here in this question. So what will be the heat transfer here? So Manuranjan, provide me the answer in 60 or so seconds. Here I should write this. This is, I think, one of the values here is wrong. So let me just quickly check it out. I think it is 5 here. So take 5 here. This is 5 bar. So apologies for the error there. The value of P2 is 5 bar. So take it as 5 bar. Determine the heat transfer of the process. So Banuranjan has given the answer minus 36 kilojoules. So let's see. So Banuranjan, this process is a polytropic process because when you will do this PV raised to the power some value n is equal to C, this is a polytropic process formula. And when you will do, if you are taking this as adiabatic process, so don't take it as adiabatic process, because nowhere it is given that the process is adiabatic. So we have to calculate n here. And what is your n coming out? If you have calculated the n, then you can just provide me the value. How to calculate n? We have this P1 V1 raised to power n is equal to P2 V2 raised to the power n, and we have P1 also, V1 also, P2 also, V2 also, and I have changed this in 5 bar. So the value was changed by me, so I hope you took that into consideration. So n is coming out as, that is the exponent here is coming out as so it is coming out as 1.285 approximately, and this is our polytropic process. So for polytropic process we need to first calculate work polytropic, which will be P1 V1 minus so let me just answer what you found. So you found first the entropy change, then you found the heat transfer. So for entropy change, you are taking this as ideal gas. So entropy change, what you are using, let's say, uh, so here you are have you calculated this by Cp formula or Cv formula? So mass needs to be calculated, then either Cv or Cp. You can calculate T2 by T1 and plus Mr ln V2 by V1. So if this is what you selected, then what is the temperature there that you have taken? Because after your entropy calculation, you need to find heat transfer. So how you are getting heat transfer from this? Are you making this delta S equal to change in heat divided by T? So after that, what how you calculated this heat transfer? Because you have calculated delta S, then what you have done? So yes, that is also one of the ways to calculate formula. So what is the temperature T that you have taken? Because here we have to take temperature T of surrounding. So is your temperature T of surrounding given here? Because heat will be transferred from the system to the surrounding, and whenever we are, so what is the T temperature that you have taken to calculate that heat transfer from this delta S? because in the question there is not given what is the temperature of surrounding. So that is the system's temperature, and that too is changing. So that 70 degree Celsius is not same for this whole process. That will change after your process has completed. So you have, first of all, you are not going to take that 70 degree temperature, because the T there in the formula of calculating this heat transfer will be constant, and that is surroundings temperature. So you should be doing so the first thing, that this is another potential mistake, and I am glad this is clear here, because this is another one of the common things that students make mistake, and you should be aware that you have to take their surrounding temperature only. But the other thing is, don't take adiabatic process, because here you have to find what is the n, and the n is coming out as 1.285. Then you have to find this polytropic process work done, which will come out as, so P1 V1, so this is coming out as minus 52.63 kilojoule, and Q polytropic, which we have discussed, is W polytropic, gamma minus n divided by gamma minus 1. So this will be giving us the answer. So the answer is coming out as minus 15.13 for me. So the minus sign will also be shown here, have to be given as the answer here, because we are asked about the heat transfer, and heat transfer we have to provide that value with the minus sign, because this will include the direction of heat transfer. So I hope this is clear to you, and I hope this is also clear why we are not calculating this delta S, because one thing is that I have not thought about calculating delta S and then calculating heat transfer. So that is very good that you thought about doing this question in that way. But remember, if you are provided with this surrounding temperature, then you can totally do this and get the right answer. But if you are not provided with this ambient temperature, then you cannot just make this heat transfer calculation as using this process of delta S. So we have this few questions left for the day, and I think we will do this questions after some time, not today, because I think today should be it for the session, and I will also take another class of this thermodynamics um, common mistake, and in that class we will cover that question and some other questions. So I am taking classes on the Unacademy website also. I've made a lot of schedule. We are going to discuss about some of the revision that I've already taken, but I am going to do their trickiest question, hardest question series, and also we are going to do a big marathon class where in this YouTube channel, where we are going to complete the syllabus of manufacturing and thermodynamics in one go for 2 and 3 or 4 hours. We are going to study in one class. So if you are interested, then you can again subscribe this channel, so that you can get notified, and follow me on the Unacademy's app. The link is given on the top of the screen, and that will be it for this class. So you can use this code. So heat transfer Manuranjan, that is also one thing that I can take, but right now I have just started thermodynamics, and there is another teacher, I think, or educator, that is currently taking heat transfer. So I have to first check out with the Unacademy's team, and then I have to tell them if I am going to take it or not. But on the Unacademy's website, I have planned a class where I will be discussing about this common mistakes in whole of the mechanical uh, subjects or mechanical engineering branch. So a lot of different, apart from this thermodynamics and manufacturing, I will also include some other subjects question or common mistakes, so we can discuss that there. So follow me there so that you can attend that class. And if you found this session helpful, this class helpful, just hit the like button, and again subscribe and hit the bell icon so that you can get notification, and share this code with your friends. And if you have other students who are preparing for GATE, you can also tell them to attend class, so that you all can discuss at the same time, and that will always be better, because it will make the environment competitive. So thank you for having this very nice discussion and answering the questions, and sticking for this hour or so. So best of luck for your preparation. Stay safe, take care. That's it for today's class.